All right, so today we are going to have a little bit of an introduction into inverse trig functions. We're going to do a bell ringer next time where we go a little deeper into what inverse functions are and review some things we discussed earlier in the year. But for tonight, just to get some notes out of the way so we're not spending our class doing too much note taking and we can do more practicing, we're going to lead into this a little bit. Which you'll see in a minute. So you should be in your new note sheet, the 9.1 inverse trigonometric functions section of your notes. And this isn't written in there, but what an inverse is, and we'll like I said, we'll talk about this next class. What an inverse is it undoes what the original function did. So when we find the inverse of a trig function, what we are finding is we're asking ourselves what angle measure produces a certain ratio. So usually what we say is like we have like the sine of pi over 6. So we're saying here's our angle. What ratio does that angle produce? What ratio of the sides does the angle produce? So if the angle is pi over 6, it means my opposite divided by my hypotenuse is 1/2. The inverse goes the other way. It's saying what angle measure produces this certain ratio. So I think I said that right. We know the ratio. The inverse helps us work backwards to find the angle that produces that ratio. So inverse trig functions help us find the angle. All right? So inverse trig functions help us find the angle that produces this certain ratio. So basically the angle is the output. I'll write that all in, I guess. The angle is the output and the ratio is the input as opposed to the other way around. Normally our ordered pairs are like pi over 6 comma 1/2 if this was the sine function. All right, so on the sine curve, the input would be pi over 6. The output would be the ratio that is produced by that angle. The inverse takes it the other way around. We know the ratio. The output is the angle that produces that ratio. So that's what we're going to look at today. So like, for example, on a drawing, we would say, okay, here's my right triangle. I know the ratio is 1/2. So we're asking ourselves, what is the angle that produces that ratio? So we have done some work with this earlier in the year. So what I would say is this inverse function looks like this. It's saying the inverse sine of 1/2 produces our unknown angle. So the angle is the output and the ratio is the input. And that's what we're going to work on tonight. So what I want you to do, on the grid below, graph the function y equals sine x from negative 2 pi to 2 pi. So I gave you a little table of values here to help you organize your thoughts. So what I am doing, and I didn't type it all in, I don't know why I didn't do that for you, but you can do it. I want you to go all the way from negative 2 pi to positive 2 pi and go from negative 3 pi over 2 to negative pi over 2. You can see my chart there. So just to get you started, we know sine of 0 is 0. Sine of negative 2 pi is 0, and then we can kind of work backwards from there. So if you need to go to your chart. If you need to graph first, actually that might even be easier to graph first and then fill in your table of values. So that's what I'd like you to do now. So I would like you to pause the video, and actually you can do the same thing for cosine, which is on the next page of your notes, and then tangent, which is on the page after that. So fill in your charts. We'll go over them in a second. Graph your functions, and then I'll tell you your next task for those inverse functions. So please pause now, and then we'll talk. Okay, so hopefully you paused and you did that math, you did your graphs. So that's what sine looks like. There's the table you should have completed. And that should be something that's very familiar to you at this point after the whole unit we did on graphing trig functions. So what we're going to work on a lot next class is how we take these sine, cosine, and tangent functions and turn them into the inverse sine and the inverse cosine and the inverse tangent. So notice this is not reciprocal. This is not secant, cosecant, and cotangent. This is the inverse function. So if you recall, when we graph the inverse of something or when we find the inverse of something, we switch the x's with the y's. So what I would like you to do, this is what your graph is going to look like. I'm essentially just changing the x-axis with the y-axis. I'm changing my domain with my range. I'm changing my inputs with my outputs. I'm changing my x's with my y's, if I didn't say that already. So you can go ahead and sketch that same scaling, that same set of axes in on your next 3 pages as well. So while you're doing that, make sure your sine function looks good. Make sure your cosine function looks good. And it looks like my graph got nudged to the side. That looks a little better right there. So make sure your cosine function looks good. All right, so if I'm skipping and you're doing other things, just make sure you pause and come back to look at these. And then please make sure your tangent function looks good. All right, so there, let's see. Oh, I guess that's a little off. That's okay. So that's what I'm looking at right now. We have our tangent function. We see where the tangent is undefined. We see where the tangent is 0. Hopefully you have that in your table of values. All right, the other point I put a little dot on, and this is going to help you when you do your inverse. We know at pi over 4, the tangent value is 1. So that might be an ordered pair just to keep in mind. So when the x is pi over 4, the y value is 1. So keep that in mind for your tangent. So now what I'd like you to do, and you can again pause for a little bit, and I will walk you through a little bit of the first one. We'll come back to all those notes I just skipped over, don't worry. There's my sine function. So what I want you to do, after you scale your axes like I have them over here, well, I guess that's kind of off the side of the paper. That's okay. Yeah, everything is scaled fine. What I would like you to do is graph the inverse relation. Notice I didn't use the word function there. We're going to talk about that next time. I want you to graph the relation x equals sine y. So really all we're going to be doing is flipping the x coordinate with the y coordinate, switching the domain with the range, switching the input with the output. So instead of the point negative 2 pi 0, which is right here, on the inverse, we're going to be graphing the point 0, negative 2 pi, which is right there. 3, 1, 2, 3, 3, 1, 2. So my graph did get a little skewed there when I transferred it over. Sorry about that. But your scaling is hopefully you counted by 3s or 2s or whatever. And instead of the point negative 3 pi over 2 comma 1, which is right there, we're going to be graphing the point on my inverse relation at 1, negative 3 pi over 2. So it's going to be right there. So that's what I'd like you to do for the next, 5 or 6 minutes, however long it takes you, because you'll have me paused. I want you to try to graph the inverse sine, the inverse cosine, and the inverse tangent functions. And then I will put my work up there so you can check to make sure you have it in there correctly. The tangent is one you have to be the most careful of, I think, but use the table of values where you can just interchange your x with your y coordinates. All right, so please pause now, and I will show you what I came up with when you unpause. All right, so hopefully you really paused and you didn't just pretend. So there you see my inverse sine relation. So I flipped my x's with my y's, and the graph looks like that. So please take a minute to just to confirm it looks the right way. It's not just a reflection. Let me say it again. It's not just a rotation. So there's something else happening that we'll talk about when I see you next time. But please pause. I'm going to go on to the cosine function. So there's my cosine of x. And there's my inverse of y equals cosine x. All right, it looks like my graph disappeared. There's the end of it. There we go. That's not pretty, but you guys got the idea. So that point at the bottom there should be 1 comma negative 2 pi. I don't like how that looks. 1 comma negative 2 pi. That's a little better. Okay, so make sure that graph looks correct on your paper. And then tangents. So there's my graph of y equals tan x. My zeros are at negative 2 pi, at negative pi, at 0, at pi, and at 2 pi. My asymptotes are all the values between those. And I know the point pi over 4 comma 1 is on my graph of tan x. That tells me the point 1 comma pi over 4 is on my inverse. Okay? At 0, the tangent value is 0 when the radian angle measure is 0. And then I can kind of work back the other way. So at negative 1, my output would be negative pi over 4. The asymptotes are at pi over 2, negative pi over 2, negative 3 pi over 2, and the zeros are all the places in between. So that's kind of the way I build this inverse tangent graph out. It's a little more challenging because it's harder to tell which way it's going to go, but that pi over 4 point is very helpful. So that's what my graph looks like. So you can see I put a little star next to that point that we can connect the dots with. Okay, so there's my graph of x equals tan y. Just switching the x's with the y's, keeping close track of where my zeros and where my asymptotes are. Okay, so what I'm going to ask you to think about on the Google form tonight is this word relation. So this is a relation. It's not a function. I was very careful with that. We know a function, each input can only have one output. So it has to pass the vertical line test, which you did back in Algebra 1. This x equals tan y obviously does not pass the vertical line test. So our job next class is going to be to restrict the domain of our tangent function to force the inverse to be a function, right? And a relation doesn't help us. We need functions. So that's what we're going to start on next class. So I ask you to think about that. What can we do to make this inverse tangent, inverse sine, and inverse cosine, turn them from relations into functions? All right. That's all for this time. If you have any questions in this video, let me know. Otherwise, I'll see you in class. Bye.